Hi, this is a video to support our abstract entitled On Assessing the Value of Simulation for Robotics, which was submitted to the second workshop on closing the reality gap in Sim2Real Transfer for Robotics at RSS 2020. The authors are myself, Liam Paul, and Anthony Corchain, who are with the University of Montreal, Mila, and Dockytown. Roboticists have long had an ambivalent relationship with simulators. Rod Brooks famously quipped, "Simulators are doomed to succeed," articulating the view that robotics research was only really truly valuable if it worked on a real robot. Recent learning-based paradigms have caused us to rethink this position, but too often the different uses and values of a simulator are conflated, and that's what this work seeks to address. Let's start by setting the problem up. A robotic system comprises an agent and an environment. The environment is controlled through commands generated by the agent and sent to actuators. The environment is observed by the agent through observations generated by sensors. Similarly, a simulation contains an agent and an environment model. Instead of a real actuator, the control commands are issued to a dynamic simulation, and instead of real sensors, the observations are generated by a renderer. The agent might be the same in both settings, or there might be some method used to help it transfer from the simulation to the real environment. The performance of the agent is determined by how well it does according to some metrics that define the specified task that it is set out to achieve. In some cases, like reinforcement learning, this performance can be fed back to the agent to help it learn over time. If we analyze this mirrored setup a little more closely, we can see that a so-called reality gap or discrepancy between a simulation and the real world can be generated at several stages along the way. Moreover, one would reasonably expect that these reality gaps would compound where upstream errors are exacerbated downstream. So let's take a first stab at evaluating this reality gap. A naive approach might be to take a sequence of control commands and apply them equally to both the actuator on the real robot and the dynamic simulator in the simulation. We can then look at the observations that are created at the output and compare them. For example, with a pixel-wise norm in the case of this stream of images. I argue that this approach has some serious limitations. First, it does not help us to identify the cause of the reality gap, i.e. to determine whether our dynamic simulation, environment model, or rendering is the root of the problem. I'm not going to address that limitation here, however. The second limitation is that it does not at all consider the task to be solved. My main claim here is that it is ill-posed to evaluate the reality gap without considering the specific task. Finally, this pixel-level accuracy may not and should not be needed for the simulator to have value as a tool for teaching a learning agent. In this work, we propose to explicitly separate the value of a simulator into its value as a predictor of reality and its value as a teacher of learning agents. To evaluate the simulator's value as a predictor, we propose the predictive reality gap, which is the discrepancy in performance on a specified task for an agent evaluated in simulation and on a real robot. In some cases, global accuracy of task metrics is not really required, and it's much easier to evaluate a relative predictive reality gap. This is evaluated as the discrepancy in the partial ordering of a set of agents on a specified task evaluated in simulation and on the real robot. In other words, if a simulator predicts that agent A is better than agent B at a given task, and this turns out to be true on the real robot, then the contribution to the reality gap for this pair of agents is 0. A separate and independent analysis is the value of the simulator as a tool for learning. The learning reality gap is conditioned not only on the specific task, but also on a specific learning algorithm. We define it as the number of trials needed on a real robot for an agent trained in simulation to converge to a performance at least as good as if it had been trained on the real robot from the beginning. In other words, if an agent trained in simulation and deployed on a real robot achieves the same or better performance as it would have had it been trained entirely on the robot, then for this task and learning algorithm, the reality gap is 0. For more details and the formalism, please see the submitted abstract and come to talk to us and tell us what you think. Thank you very much.